Hi, welcome to Fun at Pie videos. This is DC here. In this video, you're going to learn how to use vendor-specific commands using OMNIKEY Readers Vendor. So, what are vendor-specific commands? So, these commands are used to read the device-specific data. So, this is nothing to do with the contact us or contact cards. It's all about the reader itself. If you want to know the version of the firmware running on the device, if you want to know what the product name or the product serial number, so there are so many things you can get about the reader using these vendor specific commands. Most often, we focus more on how to communicate with the contactless or contact readers, and we almost ignore these type of commands. But sometimes it is required to understand vendor specific commands so that you can configure the reader well. Some more examples are you can either get or set the device operation parameters. Say for example, you can change the contactless frequency. Say for example, if you have a dual frequency reader, probably you can use this vendor specific commands to change the frequency of reader. You can enable or disable certain protocols. Say for example, if the reader supports say 4 types of protocols like protocol A, B and ISO 15693 and iClass, assume that you are using just one particular kind of card, say for example the type A card, then you can disable these other protocols. And these vendor specific commands are also used to send commands directly to the contact cards. For example, you can send the commands to a 2-wire protocol cards like SLE 4442 or a 3-wire protocol cards like SLE 4428, etc. And also some devices allows you to configure the LEDs, the blinking rate of LEDs, and the polling frequency and the buzzer, etc. So if you look at here, most of these functionalities are related to the device. It's not related to the card, the type of the card we are reading. So the command structure is pretty straightforward. To understand these commands, you have to go through the documentation probably a couple of times. So most of these vendor specific commands are enclosed in a predefined header. So even these type of commands, they still follow the same syntax like a class. You have a class, you got the INS, you got the P1 and the P2, you got the LC and the LC data and LE. So even with these commands, we still use the same format, the standard APDU structure. So here in case of because this video is about how to use these commands using OMNIKEY Readers Vendor. So if you look at the documentation, it says all these commands have this fixed header. The class is FF, the INS is 70, and the next P1 is 07 and P2 is 6B, followed by the command data, and this corresponds to the command length and expected output. Now P1 and P2, this is also called as the device identifier. So the best thing to know about this format is to look into the device documentation and the software development guide you get for that particular device. It's a very good interesting concept for students doing computer science. There is a kind of interesting data structure that's used here. It is called a DER. Now you have to look into internet and see what the DER is. So this is a kind of a tree structure. Now the data we pass is formatted like a tree structure, which has got a root node and the child node. When you discuss about a tree structure, you'll always have a kind of a hierarchy. You'll have the root, underneath you'll have the child and one more child and one more child and so on. So this forms a hierarchy of the data structure. And you will come across this terminology called TLV. So if you start reading documentation on NDEF structure, this TLV is very much used there. So the TLV format is nothing but there is a tag, there is a length, and there is the value of the data. So this is what the structure of the LC data you have to use. Now the tag value is a predefined constants. Again, you have to look in documentation. So the response you get from the reader is also formatted using the DER format, which again follows the same concept of having a root node, having the child node, and all these root node, child node, and child of the child node, they all follow the same, the TLV format. So with this background, I'm going to show you a couple of vendor specific commands using I'll be using OMNIKEY 5022, but you can use any, probably most of the OMNIKEY readers, they have the same concept. So if you understand using one reader data, you can also use these commands for other reader data as well. So as you can see here, I've connected my OMNIKEY 5022 reader writer. In addition to this, I'll also be using OMNIKEY 5422 reader as well. So this is the documentation, the software developers guide you can get from OMNIKEY website. This one is the contact card reader writers developers guide. Just have to search for the word vendor specific, you get this section here. And if you go to 5422, again search for the word vendor specific, you'll get into this. There are some nice example on how to use these commands. So I'll be using the commands, some example commands which are mentioned in the contact cards data. There is a nice example in this documentation. If you scroll to page number 40, you can see this an example, and even the data is laid out as a tree structure here. So I'm going to explain you this one command, and so that you can understand the rest. So as the documentation says, the entire command needs enclosing in a header, which is this, and just try to understand this in a different order. The last byte is 00, that is the LE. So it says you want everything the reader responds. So if you go from the child up to the root, so it's easy to understand. Just above that is, now this is an example that's used to read from, update the memory from the SLE 4442 types of tags. And there's one more example here about how to read from the SLE 4442. So SLE 4442 is of type 2-wire, uses a 2-wire protocol. So probably the same structure should apply for any 2-wire protocol. You can also see I think just go with the bottom one. So this is to read the memory. So in order to read the memory, this is the card specific command. So 30 address, and this, let's not worry about what 30 is all about. Okay. Now this is if you remember this T, L, and V. Now this is the value of the child node. So there are 3 bytes. So the L, the byte before that indicates 03, and the one next to that is the tag. So the tag is A0. So A0 might correspond to the read the tag. Again, the value of the meaning of A0 is mentioned in the documentation. So this is one of the child. So just above that, the whole thing, A003, A003, 30AA, these 5 bytes. So this itself is the value of a node above that. So the value has got 5 bytes. So the TLV, again remember TLV, the L of this child above this has got 5, and the tag of this called A6. A6 corresponds to a 2-wire protocol. And so if you add up all these bytes, there are 7 bits altogether, so the LC value will be 7. So once you get the hang of this, it's very easy to understand all of the commands. I'm going to get explain using at another time on this update main memory command. So again, if you look at the response you got from this vendor specific commands, even the response also follows the TLV format. So the first byte BD indicates it's a formatted response, and so this again is a tag. So the tag here is BD, and the length is 02, and the value is A000, and this is a standard status you get from any APDU. So this is supposed to be I think it's a 90, maybe, I don't know why it's 99. It's a 90 and 00. So even the response also follows the TLV format. So I'm going to show one more example. So this time the update memory. So here the first line is the envelope or the standard header. So it says, this is the value of LC. It says there are 7 bytes following that, and these are the 7 bytes. So these 7 bytes are organized as a TLV. So this time I'm going to start from the top to bottom. So here TLV, here the tag is A6, and the length is 05, and the value is obviously the 5 bytes, all these things. So here the value itself is a TLV with the tag as A0 and the length as 03, and these are the 3 bytes for this TLV. So there are, if you want to sketch the structure of this this command, you will have a TLV, and under this you got TLV, and this can go to any level. Under this you can have one more TLV. Now with this background, I'm going to show you a few commands using 5022. So this is software I've been using in all my videos using OMNIKEY Reader Writer. We have added a new screen called the APDU console, which is on the right side. If you click that, now this screen is very useful for students who want to learn the APDU commands. So the first thing you do is list out all the PCSC reader writers connected to a PC, and first I'm going to connect to the reader. So I'm going to show you how to send these commands without any tag on the reader. So it is possible to send commands directly to the reader using what is called as the control method. Now I'll be using, so the way the connection is made here is, so this uses what is called as the direct connect. If you look into the Microsoft WinSCAR DLL, it says the connect command with the parameter as direct is used to connect to a reader which doesn't have any contactless or contact cards in the reader. So you got some nice structure here. In order to communicate with the reader without any card, you have to use the control code. This is the standard control code, and here for the OMNIKEY 5022 it is 3500. So this doesn't have to be same for all the readers. However, the developer's guide will tell you what control code to use. So this I'm using 3500. There are some nice little things here. So I'm going to copy this command. Now I have got this 5022 PDF open in other window. I'm going to paste this command. So we can go through this command quickly. This is a vendor specific command. The reason it is because it has got the standard header. So this has got 8 bytes. So these are the 8 bytes. And now I think you are familiar, now you understand how to decode this DR or TLV format. The A2 is the tag followed by 6 bytes. Again, this is one more tag A0 followed by 4 bytes, and these are the 4 bytes. So if we press, now here you have to, if you're using this software, you have to tell what separators are there between these bytes. There is a space separator. I'm going to use the space. When you hit this send, and you can see the logs, and also there is a lot of information here. So the software says it's using SCART control with the control byte 3500, and this is the command that's sent to the reader, and this is the response we got. So if you look at the documentation, again there is a correlation between the command you send and the response you got. So BD is a positive response, like you can also have probably FD. So BD is a positive response. It's a formatted response which has got 3 bytes. Again this again is a TLV format. If you ignore this 9000, these are the standard status word, then all these things are part of the TLV block. So 03 followed by 8001. Again 80 is a tag which corresponds to the 80 what you have sent, and this tag has got a length as 1 byte, and this is the 1 byte here. So the documentation says the value of the TLV version is just a byte. Again, this is a parameter that is within the reader. So the documentation says you can only read this parameter, you cannot change this parameter. Probably in the later part of the videos I'll show you how to change some of the parameters. So I'm going to use one more command called the product name. I'm going to copy paste here. I'm going to send. Now here again, so you're already familiar how to decode this TLV block. This is the tag, this is the length, this is the tag, this is the length, this is the tag, and this is the length, and this is the command. And I got some responses here. Now if I've got some little magic here. You can either see this response in hex, or you can also see in characters. If I click this thing, all these bytes are converted to characters. You can see that the product name is indeed OMNIKEY 5022. So if you want, assume that you written a software, you want to show the name of the reader on your software, you can send this APDU and get this the product name. So likewise, there's so many commands listed in the documentation. I shall leave that to you. Something which is of interest probably is the serial number. So if you are sometimes if you want to contact the support, they might ask you the serial number. Probably this will be useful. Send that. There is something over here. If you see this thing, this is the serial number of this device I've connected, so you can find this out. Probably you can use this as part of your security measure. Maybe assume that you want your software to work only with the device of a known serial numbers. So if you have a database of serial numbers, you can look up the serial number and just make sure the reader is what you want to access. So one more interesting thing which I will be using in my next video is about the Eeprom size. So in my previous videos I mentioned that some of these reader rates from OMNIKEY, they do come with some Eeprom which are very which are useful to store some customer specific or installation specific data. So I'll be in my next video will be about how to read and write. So this is the command structure that returns the size of the memory. So if you go through that, so here 94 is what the tag we have sent, 02, and these are the the bytes, okay, which tells you the size of the EEPROM in the device. So if you decode this, this is in a hexadecimal. So this is 0400. When you convert this to decimal, you get 1024 bytes. So now you know this device has got 1024 bytes in the EEPROM. So next I'm going to show how to send these commands when you make connection with the card. So first step you do is connect to the reader. Now I'm going to place any random card. I have placed a MeFair Classic 7-byte UID card. Hit this connect to card, and you can see I have used a command called scard reconnect. So this is the command which I have started to use recently. Now this command is used to promote a connection that is made without the card to the one with the card. So this is something the documentation mentions, so we would like to use it. Now I'm going to run this a different command this time. So I don't have to use this control code because I have connected to the card. I'm going to remove the control code. So when you hit this send button, so yeah, you got some error message here. That's because I have to tell the software that these bytes are separated by space. Send. So this time you can see you got lots of information here. So if you convert this to a character, you can see this is called the firmware label, and just the entire concept still applies here. This is in a TLV structure, and the response also in the TLV structure. So you can also send this you can also use this control command when the connection is made with the card. So I'm going to key in back the 3500 control code and hit on send. We still get the same answer. If you see here, so when the code is present, the software uses scard control. When the code is not present, the software uses the scard transmit command. So this will be helpful for students. So you have to know that if you are using a control code, you have to use this the API function called scard control. So now I have connected my OMNIKEY 5422 reader writer. This is the reader writer I bought very recently. So we still use the same screen. It's the same method, connect to reader. I'm going to take one more command. This time it will be the vendor name. Copy paste, and we are going to use this control code 3500. If it works, it means 3500 is valid for OMNIKEY 5422 reader writer as well. So if you convert to character, the vendor name is called HID global. So just don't want to go to any more examples here because the concept is the same. So what we just saw is these command structure will also work with the 5422. I'm going to show you something interesting this time. So we are going to read a SLE 5542 tag using this vendor specific command. If you look at the documentation of 542 developers guide, there is a nice example using vendor specific commands to read the 2-wire protocol. So this is the read the main memory. I'm going to copy this and paste here, but here the YY is the address of the byte I want to read. I'm going to put the address 00. So I'm going to cut here because the clear button clears everything. So I would like to send this command without connecting to the card and see if this thing works. Send. Now here, so I'm not sure whether the data you returned, if you look at the data here, you got 9E. This is a 9E is an error. So looks like you have to first connect to the card. Now I'm going to send the same command this time. Look at that. So this is the, I know this is the write byte value, because I know this SLE 5542 has the value A2 at the 0th address. So what has happened here is when you hit this connect to the card, so looks like we are initializing this device to work with the 2-wire protocol. So once it is connected, you can start using. So this is a very nice example. You can try out all the various commands of SLE 5542 using these vendor specific commands. So I'm going to read one more byte, because these are the commands specific to the chipset. So there is no command to read more than 1 byte. You have to read a single byte every time. So read the address from 01. Now I know the value 13 is the right byte. So this time I'm going to send without using the control code. It still works. So what you just learned is I can send this vendor specific commands either in control mode or without a control mode when the connection to the card is established. So if you want to communicate with the card, you have to first make sure the software connect to the card using this WinSCard connect command. So I think that's all in this video. To summarize, what we covered in this video is how to use vendor specific commands using the OMNIKEY reader writers. So we have learned what is that TLV command structure is, and also how to decode the response that's also in the TLV command structure. Okay, thanks for watching.